Hi guys, welcome back to my channel, The Data Odyssey. Till our last video, we have discussed all these metadata tables, right? Now in this video, we are going to discuss these two metadata tables. I'm sorry, these two, right? I'm gonna miss out this one because there's a certain reason behind it. I'll teach you a certain concept in my next video, and that's very important and that's very unique to Apache Iceberg itself. All right. So in this video, we'll discuss this one and this one, these two metadata tables, and finally we'll understand that how to utilize all the metadata tables, right? This set and this one, with an exception of this, in order to run them in production by joining them, right? So we'll understand that how to utilize these tables in conjunctions in production environment and just to handle different use cases in production, just for the optimization purpose. All right. So let's not waste our time and get into this. Okay. All manifest metadata table. The all manifest basically metadata table provides detail inside into every manifest file across all the valid snapshots in the table. Okay. Now, what do I mean by valid snapshot? We have understood about the manifest metadata table previously. All right. And in this video, we'll understand about the all manifest metadata table. What's the basic difference? So the manifest metadata table basically consists of information for the current snapshot, not or for all the snapshot. What is all this? What do I mean by all the snapshot? We'll understand that. All right. Basically, it helps in understanding the state and organization of your data at a more holistic level than all the data files table. So what does it mean? Let me just run this basic query and let us understand that what does this table consist of. So prior to this, just know that this table structure of all manifest metadata table is quite similar to the manifest metadata table. All right. You've understood about content in our previous video. Just go through them, right? This path, it's all same, right? This consists of the manifest files because this one does not have any snapdash in its file path. All right. Now, this one is the length column 627.5 for the first record, 627.5 for the final record, but in between the record is for this particular manifest file, the record is 6208, right? Now, here comes the challenge, or here comes the exciting part. What does this table basically contain, which the manifest metadata table did not have? Just have a look at over here. The added snapshot ID. The first and the third record have got similar values, but the second record has got a different value. What does it mean basically? So let's not get confused. Let us try to understand what does it have. Okay. Now, a particular snapshot ID, it has certain set of data files added. Just to give you a context, we created the table, we inserted 3 values into it, and then that's why this set of manifest files and list and snapshots got created. So this particular snapshot had 3 data files in them. Okay. If you look at the previous video, this one was the first snapshot. Okay. Then what we did, we altered the table and then we inserted values into it. So what happens basically when we inserted value into it, a new snapshot got created. And this is the particular snapshot ID associated where I can see that we have got one data file added. Correct. So that's not an issue even. So till now we have understood that this particular snapshot actually had 3 data files added to it, and this particular snapshot had 1 data file added to it. But you might be having certain confusion. If both of these are same, then why do we have similar records in both across both the rows? Correct? The snapshot ID is same, the added data files count is same. I do understand that this one is different, but these two are same, right? This is a general question that everyone might have. So how will we differentiate it? Prior to it, we have understood these set of columns, right? Existing data files count. Did we update any existing data file? Deleted data file count. Did we delete any data file in our scenario? And this set of columns are related to the delete file scenario, where you delete a certain record from the table and a delete file get added, and multiple scenarios like did you update any delete file or did you delete any delete file? This kind of scenarios we have discussed in our previous videos, correct? Just go through them. Have a look at over here. The reference snapshot ID. That's what I was trying to explain to you. The first record has got the reference snapshot ID, which is 543 and then 546 at the end. and the added snapshot ID, which is 543 and 546 at the end as same. It's all same, right? Then the second record is something different, right? No, it's not different. It's 278 and 475 at the end, and it's 278 and 475 at the end. Okay, I do agree. There's no difference, but finally it has got a difference. It's 278 and 475 at the end for the reference snapshot ID, but it's 543 and 546 for the added snapshot ID. That means what? So 543 is the initial set of 3 characters and 546 are the final set of 3 characters. So what do I mean basically? Basically, what is happening is initially I added a particular set of records to the table when I created the table. A particular snapshot ID was attached with it, correct? Then what I did, I altered the table. I inserted value into it. But and then another snapshot ID got created. I do agree. I do not have any problem. But in the new snapshot ID, what happened? Will you miss out the records which are previously present in our older snapshot? No, right? The new snapshot should even have the data files which were present in our older snapshot. You just don't want to miss them out, correct? And that's what is happening. Basically, this new snapshot is this one. So the new snapshot and the associated set of snapshot IDs with it and manifest files with it are actually in this particular table. So the new snapshot has this one, 278475. Now it will contain the newer added record. I do agree, but it should also contain the set information related to the set of data files in the older snapshot even, right? So the reference snapshot is the final snapshot and the associated branch or chain of snapshot with it is in this added snapshot ID. Okay, let us have a look at in this diagram. So I've just created this diagram. We have seen, right? This is our older snapshot. This older snapshot, I created a data file, right? It's correct. Now, in our newer snapshot, what I did, I added one more data file, but because I added one more record. But do not you think this newer snapshot would also have the older data files for its information, right? For its purpose of snapshot, for snapshot purpose of version, like when you query even the most recent version of the table, it should contain all the data file. It should contain all the manifest files associated with it, correct? So 3 data files in the older snapshot, 1 data file in the newer snapshot. They are added. I do agree, but the final set of data files associated with this snapshot should be 4. The older 3 data files and the newer 1 data file. So that's 4, correct? That's why this is the reference snapshot ID. So just understand the final snapshot ID by which you'll understand that which is my final snapshot ID. This one is my final snapshot ID. Okay. This one is the final snapshot ID for the initial 3 records. This one is the final snapshot ID for the initial 3 record plus 1 record added. And the associated desktop snapshot is the older snapshot and also the newer snapshot. Okay. That's what happening. So if I just, we'll get this more clearer. Okay. So let us try to understand this. Let me just comment this out. Let me just run this query. You'll just get to know that why I'm telling this. So the newer snapshot should have the older data files associated information and the newer set of data files associated information. So this one is the newer snapshot as we have seen. And then what is happening? You see there are 2 records. The reference snapshot ID is 278. All right, I get it. This is the most recent snapshot ID, but I know that it should consist of my older data files information. So how will it go? It will understand which is the snapshot ID associated. Okay, the older data file have the snapshot ID of this one, and the newer data file have the snapshot ID of this one. So both this snapshot ID get combined, and finally this snapshot ID is the snapshot ID which will be kept over here. So the final set of data files and their associated snapshot IDs will have the same snapshot ID as the reference snapshot ID across both these records. That's what is happening, right? So 2 manifest files are associated with this particular final snapshot ID. Okay. So reference snapshot ID is the final snapshot ID. Okay. The final version. All right. So let me just comment this one out and then we'll understand that how many data files are added per snapshot. I told you, right? What I've explained over here. The older snapshot should have 3 data files associated with it, and the final snapshot which should have the 3 data files of the older snapshot, which is the added snapshot of the older set of data files, and the 1 data file, which is the added snapshot of the newer set of data files. Finally, this snapshot should have 4 data files, correct? Let me just run this query. and what we expect that should happen. Let us just have a look at it, and you see that's what's happening. The older snapshot ID has got 3 data files added, and the newest snapshot ID has got 4 data files added. One related to three data files associated with this snapshot, and 1 data file associated with this snapshot. Okay, that's what's happening. You see, we are getting the entire understanding of how many data files are added per valid snapshot. How many data files are there actually per valid snapshot. We are not just focusing upon the added data files. We are focusing upon the entire set of data files per snapshot in this all manifest metadata table, which if you look at the above manifest metadata table will not have. Okay, you see over here what's happening, that how many data files were only added. It's not focusing upon the entire set of data files associated with the particular snapshot. So the older snapshot has 3 data files added. I do agree, that's what it's given, and that's what it's coming in the all manifest metadata table. But if you look at over here, the newest snapshot has only 1 data file added. That's what's showing over here. We know it has got 1 data file added, but it should also contain the information of my previous snapshot or the previous set of 3 data files, which I can actually observe over here, right? So basically, the all manifest metadata table consists of all the valid data files across the valid snapshots. All right, that's the entire, and this one is the manifest length, right? We have understood these things, correct? It's combination of the older manifest length, older snapshot ID manifest length, and the manifest length of the current added snapshot ID. All right, so that's what it is. So we have understood about all manifest metadata table. Now we have the entries metadata table. What is it? The entries metadata table details about each operation that has been performed on the table state and deleted files across all snapshots. This basically helps us understand the evolution of our dataset. Let me just run this query and let us just understand that what does it mean. Okay, run selected test. You see, status is 1, snapshot ID is this one, and the associated set of data files are this. Okay, so what I've told, my older snapshot ID had got 3 set of data files associated with it. That's what it's doing. It has got 3 data files associated with it. And then my newest snapshot ID had got 1 data file associated with it. That's what it's happening, right? Now, one more thing, that status. We'll understand that what does the status column represent? Okay, do we have a status column? Right, status column. It's 1. What does 1 mean? It's added, right? Did we update anything upon the existing data files? No, right? That's why it's 0. That's why it does not have 0 basically. So 0 indicates existing data files. 1 indicates added data file. We added data files, right? We continuously added records into it. That's why it's 1. And suppose if we delete any data file, that information will also get stored over here. Suppose if you delete any particular record, the data file associated with it will get deleted, right? And a delete file will be created. Then the status would have been 2 over here for that particular operation, correct? So that's what is this one. And finally, let me just run this query. What you'll understand, total size of data files added per snapshot. Okay, let me just run this query, run cell. Okay, column in bytes. Okay. File size in bytes does not exist. Okay. All right. Sorry. Let me just run this query again. You have a file size in bytes column. Okay, it does not have it. All right. So basically, what has happened is like maybe in the older version, this one was present, but in the newer version, this one is not present. So you might need to join it upon a particular files metadata table, and then you will find it out. Okay. So that's why you will not get information with respect to this total size of data files added per snapshot from this table. So let me just comment this out. It's not required. Maybe we'll require, we'll look at it sometime else. Okay, like not sometime else. What I mean is basically we'll look at while understanding metadata tables in conjunction. Let us just utilize this because this one is the most important thing that we'll do. So you have understood, right? The this one entries metadata table actually helps us understand that what kind of operation were performed upon the table, right? For on the data files, right? So like it helps us understand the evolution of the data file, whether that particular data file was added. We can understand it using this a status as 2, whether it was sorry deleted, then it is status as 2. Then suppose if you say that a particular data file was added, then the status is 1, which we have actually done. And if we have updated any existing data file, then it's 0, right? So it's that kind of operations which were performed upon the data files. All right. Now finally we'll try to understand these using these metadata tables in conjunction. What does it mean? Okay, so let me just run this one. Get all data files, get data on all files added in a snapshot. Okay, let me just run this query and we'll understand it. Do not worry. E.file path does not give me one f.file path. Okay. E.file path. E.file path. Okay. E.data file. Okay. E.data file. So I'm just correcting the queries on runtime. Do not worry, but it's gonna be all fine. All right. Type is small difference in this host when counts. So if f.file path, it's e.data file. Okay, data file. Okay. So what will I do? Data file dot file path. E.data file dot file path. Will it work now? Then selected text. It's running, right? So what I did basically is this is the file path upon which I'm trying to join. All right. So file path is present within it. It is a struct kind of data structure, correct? So within the data file, I need to access the file path. What I did? So data file dot file path. This one I'll join upon f dot file path, which consists of the file path only. All right. And see, we got the value over here. Correct. What did we want? Basically wanted get data on all files added in a snapshot. Okay. So in a particular snapshot, I wanted to find out the added data files. So you see this particular snapshot 543, and then finally wait. Let me just okay. Oh, okay, this is not something to worry about. So basically what it is, so this is the older snapshot that we have, correct? So this particular snapshot, set of snapshot had got 3 data files associated with it, right? We get the entire set of information, the lower bound and upper bound for that particular data file, and the files as in bytes of that particular data file, and whatnot. The partitioning, the particular information, the particular data file contains information with relevant to which partition, the kind of file format, the file path, everything. We get each and every information with respect to the added data files per snapshot. Okay. Then the snapshot ID, this one, the latest snapshot ID has got one data file added. That's what we have discussed previously. And that's why the upper bound and lower bound is there. And then the associated column sizes, value count, null value counts, everything, record count, partition, file format. All right. We have got all this information. These columns we have understood in a previous video, right? I don't want to again and again explain the same thing. You can just go through my previous videos and get to know all of these columns, right? So just by running this query, we got to know that what are the data files added per snapshot. That's what get data files on all files added in a snapshot. Get a detailed overview of the life cycle of a particular data file. We'll now need to understand this. Okay. What kind of operations has been performed on a particular data file? Okay. So let me just run this query. Unselected text. Okay, e.datafile.file path. E.datafile.file path. It should exist, right? Okay, it should be underscore. That's why it's not working. Okay, let me just run this one again. All right. So see, get a detailed overview of a life cycle of a particular data file. What I've done, I've just queried upon a particular data file. Okay, I've just filtered out a particular data file and what kind of operations has been performed upon that. Okay, now what we have done on the table, we have just added records into it, correct? And what we have discussed over here, that for added data files, the status should be 1, correct? or it should be 0 when we update any existing data file, and it should be 2 if we delete any particular record and that particular data file has got deleted, right? And a delete file got created, then the status should have been 2. But what we have done, we have just added records into a particular table, correct? So whenever I particular upon query upon this particular file path, what's happening is only a single operation has been performed on this particular data file. It only record has got added. That's why the status is 1. And that's why you can see that the snapshot ID with respect to this particular data file is this one. There is no deletion of data files. Did we add any data file? Right? We added one data file, correct? That's what we discussed. And the snapshot ID is this one. It's all done, correct? Now, let me just remove this where clause and let's see what's happening over here. Let us see that what kind of output does this give. You see what's happening right now. You are getting the information with relevance to all the data files. Okay. Now just have a look at over here. In this particular snapshot, 3 data files were added. Now why there are 3 records? Because since 3 data files were there, so 3, 3, 3. Okay, for this particular snapshot. All right. And then we have got one data file for what? The newer snapshot. So the added snapshot ID is this one. We know what is added snapshot ID. And when in the newer snapshot, we added only a single data file. That's one. Okay. Why 3 records with respect to a single snapshot ID? Because across this set of these snapshot IDs, we have got 3 data files, right? So for this particular snapshot ID, we have got 3 data files. So since 3 data files were there, so 3 records. All right. And finally, let me just run this query. Track the evolution of table by partition across snapshots. We'll understand the evolution of table by partition. Okay. Now let me just run this query finally. E.file path, no. E dot what? Data file dot file path, correct? That's what we had done wrong across our queries. Let me just run this one. You see, using this query, what I try to be, how many snapshots were added? How many data files were added per snapshot across the set of partitions? Okay, just have a look at the way. What do we know? Initially, we added a single record into the table. We added 2 records into the table. All right. So in this particular snapshot ID, 2 records were added. Sorry, we added 3. Obviously, I do agree. But we added it across 2 different partitions. One was across sales and one was across technology. Okay, you get it? Now, so for sales, we added 2 files. We added 2 records. For technology, we added 1 record. Both of these are with relevant to the initial snapshot that got created when you added 3 records to the table. Now, across those 3 records, we had 2 records associated with business unit equal to sales and 1 record associated with the business unit equal to technology. So for business unit equal to technology for this particular snapshot, I have got 1 file added. And for business unit equal to sales for this particular snapshot, I've got 2 files added. Correct? Now for this snapshot, I added only one snapshot. I added only 1 record. That's why 1 data file got created, and it's also with relevance to technology. That's why 1 data file is added for this particular partition technology in this particular snapshot 278475. Correct? So we only saw all those data files which were added per partition per snapshot in this particular query. I will attach this particular IPNB file in my YouTube in my description, and you'll get to understand. You can just run these queries on your own in your local data in your own Databricks environment. Correct? So if like just for out of curiosity, if you say what will happen if you run e status equal to 0? Did we touch any existing data file? No, right? So it shouldn't return anything. Let us just check it. It is not returning anything. And did we delete any data file? Did we delete any data file? Let me just run it. Again, it's not showing anything, right? So yeah, guys, thank you so much. Whoever has been till the end of this video. It was a very important video. In our next video, we'll understand something very exciting, something very unique with respect to Apache Iceberg. Okay, just stay tuned to my channel because we are going to like unravel certain production use cases in on my channel, and we'll get to know that what can be done with these metadata tables, what kind of exploration, what kind of optimization can be done, right? So if you look at these kind of queries, then you'll be able to understand that, guys, that metadata tables is of quite high importance of for any data engineer in production use case for optimization, right? Thank you so much. Bye bye.